Hey everybody, this is Graphing Rational Functions 2. So this is my second video on graphing rational functions. I'll move a little bit quicker because I talked about the basics in the first video. So in this scenario, what we're looking for is types of rational functions where the degree on the top is the same as the degree on the bottom. So what I'm talking about there is you're looking for the highest power of x on the top. Well, the highest exponent on the x on top is 1. And then we check the bottom. So I have an x plus 2. The highest exponent would be x to the first. So the degree on bottom is also 1. So when your degree on the top is the same as the degree on the bottom, I'm going to talk about what you do as far as graphing this rational function. So in my previous video, I had talked about how finding that center point really helps you with these follow-up questions and it helps you with this graph. So our goal is still to try and find that center point. So here's how we're going to do that. The first thing we're going to focus on, and kind of the big thing we want to avoid, is dividing by 0. So what I'm going to do is I'm going to take the denominator, that x plus 2, and I'm going to set that equal to 0 and solve. So when the degree on the top and the bottom is the same, take the denominator, the bottom, set it equal to 0, and solve. So if I'm trying to solve this for x, I would subtract 2, I would subtract 2. I'm going to get x is negative 2. To find the y value, what we need to do is take the leading coefficient on the top and divide by the leading coefficient on the bottom. So the leading coefficient on the top is, well, the first number that shows up in the front on the top, which is 5. The leading coefficient on the bottom, it's not written there, but when you have an x like that, the leading coefficient is 1. So we're really looking at 5 divided by 1, which is just 5. So my center point is going to be at negative 2, 5. So that's going to be pretty important to us. I'm going to write that down up above. So as I go through graphing this, I'm going to go ahead and find where that center point is so I can draw my asymptotes. So I'm going to go left 2, up 5, very lightly put a point so I know where that center is. I'm going to draw in a horizontal asymptote there, as well as a vertical asymptote. Now I got to figure out where these branches at. Now in the most basic of our rational functions, the branches are going to be in the bottom left and the top right. I'm not quite sure if they're still going to be there or if we're going to flip the other way. There's two ways of checking this. One way is you could just start plugging in x values, any of these x values from negative 10 to positive 10, plug them into the function and get y values and start plotting points and figure out, all right, which corners are we in. Another way is you often have a graphing calculator available to you. So what I'm going to do is I'm going to take this and throw it in a graphing calculator, but I do want to be careful. Put parentheses around the top and put parentheses around the bottom when you have multiple terms there. Otherwise, the calculator does get a little bit confused on what you're trying to graph. So what I did is I went to y equals. On top I put parentheses 5x minus 3, a division sign, and divided by parentheses x plus 2. Now when I graph this, this is what I see. Notice you don't see asymptotes there. That's something that we draw, a calculator is not. But I can see that one of my branches in the top left, another one of my branches in the bottom right. So I'm going to do that exact same thing here. A branch in the top left, a branch in the bottom right. So you're going to start close to an asymptote, jump across, go to the other asymptote. Start close to an asymptote, jump across, go to the other asymptote. Now again, I'm just rough sketching here. If I wanted to be a little bit more precise, I could definitely sit here and look at the table from the graph and try and plot a whole bunch of these points. But I'm just comfortable right now with a rough sketch, so I don't need to sit here and graph things, especially with all these decimals. So follow-up questions. We have domain, range, horizontal asymptote, and vertical asymptote. I'm going to start with my asymptotes first, and then I'll work on domain and range. So the horizontal asymptote, we've talked about it. The equation for this horizontal line, you're thinking hoi vux. Horizontal, hoi, works with y. In fact, it's going to be y equals, from that point, 5. That is the equation of this horizontal line. For a vertical asymptote, or a vertical line, we're thinking vux, V-U-X. Well, we're going to have x equals, in fact, negative 2. So these are going to be my asymptotes for this graph, y equals 5 and x equals negative 2. When we move on to domain and range, we're asking what are the x values that we could plug in, and what are the y values that I can get as an output from this function. Well, I could plug in all real numbers. Any x value that you come up with, you could plug into this function, except there's one x value that we should not be plugging in. So we're going to say x should not be equal to -2. Notice anything that deals with x deals with the x value of that center point. Anything that deals with y is going to deal with the y value of that center point. The reason we do not want to plug in -2 is if you plug in -2 into this function, in the denominator, that's going to simplify to a 0, and we do not want to divide by 0. For the range, this is what are all the y values that I'm going to get out of this function? Well, for all the inputs I plug in, I could get all real numbers, except there's one y value that no matter what you plug in, you're never going to be able to get it out. We're never going to have y equal to 5. And again, that's from those asymptotes and those center points. So this was graphing rational functions 2. This is when the degree on the top is the same as the degree on the bottom. So when the degrees on top and bottom match up, you take the denominator, set it equal to 0, and solve, and then you take the leading coefficients and divide them to get the y value. Once you have that center point, you're good to go. This is graphing rational functions 2. I have one more video on graphing rational functions. It will be graphing rational functions 3.